Thank you for joining us on this wet Friday night. My name's Heather Roberge. I have the pleasure of introducing tonight's speaker. He is a contemporary of mine, working in Europe. His name is Matias del Campo. He's founder with Sandra Manninger of Span Architects, which is based in Vienna, Austria. Matias was born in Santiago, Chile, and studied architecture at the University of Applied Arts in Vienna. He is a very active practitioner, working on how to integrate avant-garde ideas and practice, like so many people of his generation. So in the past, I don't know when he finished at the Angewandte, but in the past decade, he has been a research fellow here at the MAK Center in Los Angeles. He has guest taught at ESARQ in Barcelona. He's currently teaching a studio at UPenn, and he, in both 2008 and 2010, was the curator of the Architectural Biennale in Beijing for the South American section. He was also a co-author of a study on future lifestyle housing in Vienna, and most recently was an architect of the Austrian Pavilion in the 2010 Shanghai Expo. So Span's work really uses contemporary advanced design techniques like parametric design to look for the potential of new forms to do new things with the kind of basic stuff of architecture, which he calls its inherent qualities. It's space, organization, assembly, structure, and circulation. And he and his partner are interested in the sensorial and spatial experiences that are possible when form is produced using algorithmically driven approaches where external forces, he calls them intensive forces, like solar radiation, weather systems, acoustics, and wind, are used as a means of form finding for architectural bodies. So his work with parametrics spans from urban design organizations down to architectural componentry. I'm wondering where he sees the best fit for parametrics in his extensive experimentation with it. So hopefully his presentation tonight will answer that question. Thank you and welcome.
Thank you very much for the kind introduction. First of all, thank you for inviting me here to talk tonight. I have to admit that I'm a little bit nervous, so forgive me if I mess up one or the other thing, or if I forget one or the other term. As I already mentioned, what is it? Hello?
Better now? Oh yeah. Can you turn it down a little bit? Okay, great. So basically speaking, as I already mentioned, Sandra and I founded Span Architecture in 2003. I have to say, basically out of a specific desire that we wanted to continue a sort of research that we already started while we were in the university. We already were, working with computers, and there were not so many people around in Vienna that actually could provide a specific this sort of idea. So we thought, okay, we're just going to start ourselves doing exploring specific ideas. One more thing I have to say that I'm happy to be back in a way. I mean, I already was here in the time when I had the Schindler Scholarship, It is an interesting idea that there is this sort of connection between LA and Vienna. And I think that's probably because there is a specific share in terms of, let's say, desires for maybe the spectacular or the opulent. Basically speaking, if you come from an environment like Vienna, you probably have a couple of things in terms of your environment that shapes specific thinkings of architecture. But I'm going to go into more detail later on with that. First of all, I would like actually to highlight two specific ideas that shape, let's say, the architectural ideas of our office. Ideas related to the intensive, as had already mentioned also, and ideas that are related to the extensive. And I would like to, kind of include them in two examples. The first example being Iron Man. Actually, what I think about that is that what we see here is a specific idea about, let's say, a mechanical body, something that is very industrial, something that is very mechanic in a way. It is, in a way, the highlight of a development, which I think could be stated started with the Paxton Crystal Palace, as an example of an industrial production of architecture where, or a whole part relationship where you have a specific shape that is subdivided into repetitive panels and aligned to produce a specific architectural environment. In this case, of course, the smallest possibility to create this sort of idea would be this sort of this suit that actually not only is composed of specific elements, but is also, there to enhance the forces of a specific body. So that would be an idea that is completely related to extensive conditions. Extensive conditions is basically what we as architects get educated in our general education of architecture, which is thinking in specific depths, in specific heights, in square meters, in distances. So everything is very defined. Now, there's of course also an alternative method to think about spatial conditions, which I would like to show with this example here. Sunshine by Danny Boyle, who did also Slumdog Millionaire and Trainspotting. Now, what we see here is a completely different approach to a, let's say, architectural environment. It is talking about continuous forces, it is talking about an animated space, it is talking about, let's say, currents and forces, temperature and movement. So what I also like a lot about this clip is a twofold method in perceiving time. So as you can see, obviously the explosion is way slower than the action of the actor, Cillian Murphy in this case. So you see actually two elements of time in action here. One point in these two examples is also that both examples are actually computer generated, and depict the possibilities that are inherent in programs to define spaces that are, on the one side, driven by extensive ideas, but at the same time also possible to include intensive conditions. And of course, it's interesting, it's also kind of a particle animation, and there's a lot of different things that in terms of technique that would be also part to explore. Another example for the discussion of intensive and extensive systems is an example that Manuel de Landa brings once in a while, which is you have to imagine two globes, and you have one globe that is basically depicting the specific borders of countries, the borders of continents, so everything is very defined and fixed. So basically the kind of globe that you know from high school, I would say. And then on the other side, you can imagine a globe that depicts the currents of the seas, different pressure systems, the magnetic lines of the Earth. So I would say a more continuous idea of movement within these kind of conditions. Now, if we go for these ideas of intensities, which talk about weather, which talk about gravity, which talk about the variation of elements, we also have to think about how to get these sort of ideas in a possible architectural design. What you see here now is an old animation from NASA. I think it's from '98. It's the oldest one that I found. Maybe there's older ones. But actually what is interesting here is the idea of simulation. So, of course, the purpose of the simulation is very clear. The idea is to reproduce a specific system, in this case a tornado, in order to understand its behavior, meaning, which direction it's going to go, how strong is it, and so on. And in fact, this animation is a composite of two elements. On the one side, the particles, which actually get generated in the computer, and on the other side, you have the real film footage of the hurricane from space. So it is an overlay of two elements. One that is a physical reality, the other one being the simulation of that specific effect which is in action here. How does that actually influence, at the end of the day, an architectural result? Well, basically speaking, architecture always, of course, has tried to tackle the problem of simulation, not maybe with this specific term, but architecture was always about how it actually, let's say, how actually intensive forces shape the architectural object, meaning that throughout history, actually, architecture has tried to position a building, for example, following specific wind conditions or following the light that can be achieved on that site. The difference for today is that actually we have now systems that allow us to go deeper into this kind of ideas and try to understand not only the resulting effects, but actually from the very beginning try to understand how this can actually create pressures on the design. So this is one side, which is more sort of a, let's say, technical approach to a design idea. Of course, on the other hand, there's also, let's say, specific desires or obsessions about intensities in spaces that are generated by its affect. What I mean by that is, what we see here specifically is this kind of Baroque sky, and it actually depicts in a really interesting way some of the, let's say, obsessions that Sandra and myself share. I mean, as you saw in the beginning with the two examples, you can clearly see that Sandra and I are both very fascinated by science fiction. But on the other hand, we're simultaneously also very, very strongly shaped by what we see on a daily basis in the town that we work, in Vienna. I actually rather recently became aware about the fact that what I see on a daily basis in the city shaped my let's say, my sensibilities and ideas about architecture. So basically, when you go out in Vienna, you can see, from Romantic to Gothic to Baroque to Rococo to Jugendstil. So you see all these sort of very articulated and opulent spaces. And I think that there's also a very specific desire for this sort of architectural expression present in Vienna to this very day. Throughout the 20th century, I think that Vienna was trying to somehow, let's say, get a little bit of distance from that, but nonetheless, at the end of the day, it is present, it is there. It is something that is part of the culture, and what we decided to do is just to embrace these qualities, embrace these possibilities, and try to include them into our work, of course, based on computational design techniques. The fascination for Baroque elements also are based on the, let's say, rigorosity with which these architects actually tackled opulent architectural spaces by the use of geometric conditions. So, in a way, it teaches us how we can use geometry and maybe some mathematical ideas in terms of generating opulence and articulation, protrusions and extensions, in order to incorporate them in a contemporary architectural environment. One of the very first, let's say, lineages of exploration that Sandra and I did are basically considering topological ideas of architectural bodies. for us, there were actually two specific elements that we wanted to explore with these animations, which is, on the one side, openings in complex curve geometries, and on the other side, possibilities for circulation. It is not about a specific architectural project. These are basically only prototypes and possibilities that we later on started to include in architectural projects. And it is very important for us actually to continue these sort of explorations that start with something that can be considered abstract or an abstract machine for a variety of ideas, and continue with them in possible architectural projects. These, by the way, are direct results from our stay in Los Angeles. I mean, exactly this is what we were doing during our stay with the Schindler Scholarship, which gave us the possibility really to explore a specific idea in depth without having to consider any other, thing to do. Excuse me. And another aspect of our work is that we also try right away to make these results physical. So for us, it's important to have somehow a physical result emerging out of the work. It is not our goal to stay in the computer. Our goal is actually to take it out, make it physical, materialize it. This is our competition entry for the Brancusi Museum in Paris. This was actually the first time where we had the chance to include all these kind of prototypical ideas that we developed here in Los Angeles into one project, in order to understand how it actually behaves as an architectural body. I think I have a laser somewhere. Yeah. 1 second. So, what you see here in the top, this machine here, that is actually the Centre Pompidou. This is the plaza in front of it. That of being there. And for us, it was also like a possibility or an idea to try to understand how we can transform this kind of rigorous grid here into the Atelier Brancusi. So, as you can see here, this is the present condition. What you see here, that here, this is the present Atelier Brancusi, which is actually a reconstruction made by Renzo Piano. And you see how the plaza is falling down in the direction of the Centre Pompidou, which would be on this side here. And there is this triangular wedge, and actually that's something that we made use of in terms of creating a three-dimensional jump between the two levels that are present in the plaza. There's one specific thing about the work of Brancusi, which I always actually was a big admirer of his work. There he is, the old man with the beard. Which is the quality present in the sculptures, not only in terms of their form, but also in terms of how the materiality actually created a specific effect in space. That was something that I always was very obsessed with, and I was very happy actually about the competition and about the possibility to do this competition. However, I actually was not d'accord with the competition call, which was actually saying that you have to reproduce again the atelier. I mean, the reason for that is that Brancusi's will actually stated that he will give or donate his sculptures to the city of Paris under the condition that his atelier is preserved. Now the problem is that after his death, his atelier was actually demolished in the 60s, and you have to know that the original atelier was in really, really bad shape. And so the idea came up to rebuild the atelier in a specific area, and this was then done by Renzo Piano here. But I disagree completely with the fact that it was not really a reconstruction, but they actually created these kind of glazed walls here. So you have this woman just looking through a glass wall, and then you have on the other side also one. So basically it's a sort of Brancusi aquarium. And I actually thought that, I cannot imagine that this was really the idea behind it, because Brancusi's sculptures have a quality that you have to experience in space. You have to have the possibility to walk around them and really to completely experience them. And I don't think it makes fair to them just to look at them like it would be a theater or a zoo. So we actually moved away from this idea to recreate the atelier, and instead we actually tried to create a combination of different elements that would allow the visitor to really circulate around the sculptures. In terms of technique, what we did is rather simple, almost naive in a way. We actually just had a look into, let's say, the techniques that Brancusi was using for his own sculptures, and we saw that there is a recurring motif in his sculptures, which is an idea of constrictions. So he has actually a volume or a mass that he actually makes a constriction in the middle, dividing the elements into specific areas. So you can see that, for example, in the endless column. This is just a repeated element that continues up and down. This one here being La Négresse Blonde, which is actually a volume that is constricted to create two spheres, almost sphere-like, they're not really spheres. And the burden space, which actually has this kind of conical beginning, is constricted and then continues in the curved element. And we thought, okay, how about dealing with this idea of the constriction? And out of a variety of tests that we made, we got this sort of bun, this sort of semmer, and this was actually the beginning for a variety of explorations in that extent, which was an interesting thought in how you actually can combine a continuous circulation emerging out of these topological models with, let's say, compartmentization that is created by the constrictions, which of course helps to give the space in the museum a specific rhythm. Also, right away from the beginning, it is always important for us to create right away a fabrication strategy, something that allows us to think about which kind of elements come together to create the structure, to create the architecture. This was also already present in the competition stage, and you can see here just a couple of the panels that are actually present in the entire surface of the museum. The only parameter actually drives the subdivision of the elements was how big can a part be that we can move through areas without having a specific heavy load transportation, so that we can normally transport. And a specific size came out. It's like 4.50 meters by 2 meters, and actually that is the size that you can transport around with no problem. And that's how the subdivision actually was made on this body. A view from the Centre Pompidou. Actually, we have two layers. I mean, we have two levels. One level that actually holds the sculptures, and a level below that we intentionally made rather blocked from the daylight, because Brancusi's work is not only about the sculptures. He also has there's also a huge photography collection and a huge graphic collection. And we wanted to create a possibility also to show these ones as much as possible protected from daylight, which was this kind of area which was almost sunken into the plaza. And as you can see here on top, that's actually where the sculptures are standing. It would have been actually quite interesting to solve how we can create this free spanning area here with this sort of delicate thin shells with having these heavy loads of the sculptures on top of it. But that's probably something that we would have discussed with Arup. And this is the top area with the sculptures. They're loosely based, the distribution of sculptures is loosely based on how Brancusi actually put them into his atelier. So in sort of kind of recreating the idea of the distribution of elements, but not completely copying it. One idea was actually sort of sinking the museum into the ground instead of trying to be as high as possible to create this kind of low slung structure, where actually the real experience of the form actually happens when you are walking up the Centre Pompidou. So you have the chance to really see this kind of articulation in the plaza more from the top that actually you have when you're standing on the plaza, sort of camouflaging the building a little bit in the ground. This area here would have become the outside area of the cafe, and you see there's like this specific node here, which is a connection between the Centre Pompidou and the Atelier Brancusi. So, and following that, I would like to show a little bit about the Austrian Pavilion. you can see that there's this kind of specific lineage between a variety of projects that are actually dealing with a similar problem. So in this effect, you can actually consider the Atelier Brancusi, for the Brancusi Museum, like the grandfather of the Austrian Pavilion, because it is dealing with similar problems, like the circulation, the way how you enter the building, and a variety of other similar problems, like this kind of creation of the stairs that go up into the restaurant. Let me just walk you briefly through the project. I promise these are the only things I'm going to explain. The rest is just going to be more or less images. There's one thing that I have to explain about the competition. In the competition process, the site for the competition is about 2,000 square meters, and the program of the pavilion was also about 2,000 square meters, and you can do a couple of decisions on that. You were allowed to build to a height of 20 meters, that was the maximum, and that was basically it. And we actually decided to, instead of trying to fill that volume as much as possible, to do the biggest building possible, we tried actually to reduce the size of the building with the argument that we said, okay, we're going to do something small, but this is going to be, you know, in terms of architecture, excellent, instead of making a big box. And additionally, what came along with that is the fact that we moved the building to the back of the site and created an entree for the entire building at the beginning, so that we actually had the chance to right away from the beginning of the site try to control the movement of the visitor and see how they actually start to enter and penetrate the building. So what you see here in the front side is actually a ramp that goes up to the entrance. And this is actually the highest point of the pavilion on the lower floor. I'm not going to go specifically into the program. I can only briefly say this was a mountain area, this was about the woods, this was about the Austrian water, and this was about the city, just to keep it brief. But for me, the interesting part is that it is the highest point, and then you start to slowly circulate downwards into the city area. Which in fact, I mean, it was called the city area. For us, it was always sort of more the concert space. This was actually the originator of the entire building. That's what we started with. For us, it was very important to create a space that acoustically was on a high level, so that we would have the chance to do classic music, classic concerts inside that space with an appropriate quality of sound. And then on the upper floor, you have this kind of outside staircase that goes up here, and this is the restaurant area of the entire pavilion. Bar here. A huge kitchen. For us, we wanted to have a kitchen that is really functional. We didn't want to have a kitchen that just warm up food. We really wanted actually that it is in action and that you have fresh made food there. VIP area and the office space, and a garden that was open to the sky. The idea behind that garden is that if you will notice, there is actually no windows in the borders of that space, except here on the back for the kitchen, but everything else doesn't have any windows. It's only this opening in the middle, and the basic desire behind that was we knew that, okay, the expo is going to be just hysterical. There's going to be a lot going on. There's going to be a lot of people. Every building is going to cry louder than the other, and we thought it's maybe a good idea to create a secluded space that actually allows you to focus on one area only, and this was in this case the sky. It turned out to be, it worked quite well, and I have to say that with the journalists at the expo, especially this garden became very popular because you had free Wi-Fi, you could focus on writing, and you were allowed to smoke. So that's actually the things that kind of really worked there because it was actually not allowed to smoke anywhere else. Talking about the way how we work, I mean, it has a lot to do with, let's say, evolutionary processes. There's like a huge array of varying elements that are repeating specific qualities. And I mean, if you think about evolution, it is basically, a replicator that at the end of the day, by a filter, defines actually a specific result. And we had about, I think, 100 iterations that actually just, they merged all of this kind of sort of box here that consisted of the space that the interior of this kind of concert room that I was talking about before is, And then out of that, we had like a variation of topological conditions that were just unfolding from that space and creating the rest of the program. And of course, in this case, the filter is basically, the sensibility of the designer. So we decided, not only because of the form, but also because of a couple of other reasons, to go with this element here and to continue exploring what it is actually able to do in terms of space. On the one side, we have this kind of evolutionary processes. On the other side, we have, of course, the problem how to, create the let's say construction of the building. This is actually a definition I'm really proud of because it's so minimal. It's probably the smallest grasshopper definition ever. And actually, that was there for to define actually the gradient of coloration on the facade and to see how we're gonna distribute the tiles. I'm gonna talk about the tiles in a second on the facade to create this very specific facade condition on the outside. I was already talking before about simulation, and I was saying that actually intensive forces can start to shape the form of a building or of a space. What you see here is actually simulations that we ran to understand if this central space will give us the qualities that we want it to have in terms of acoustics. It is, of course, a back and forth process. It is adapting the form, analyzing, adapting the form, analyzing. The more interesting part comes up when actually you're able to directly input data from the analysis into the design process, which has become possible in like about since a year or something, where you can really actually influence the form by by a parametric process. But these animations are a little older, so actually that possibility just came up after we actually had already finished the project. But however, the idea as such is, I think, completely possible and explainable. From the very beginning, of course, including different disciplines to work on one model. So we had one master model, actually, that all the different companies were working with, which turned out to be quite successful in the sense that working with Chinese companies, it can easily happen to you that they come up and say, hey, we have to lower the ceiling 1 meter because we have to put some pipes in there. And you say, no, it's impossible. We cannot change that. We cannot change that because otherwise we don't have enough space. And we introduced these companies actually to some building information modeling software, making them understand that they can actually simultaneously see where the problems are and how they can actually tackle them, instead of trying to put multiple layers of function on top of each other. It can be one layer that actually includes everything that is needed. As I said, the building is small, and the height of the ceilings is really, really low. One of the engineers who was included in this project was actually saying that this project is less to do with architecture than with aviation, in a sense that you have to put a lot of functionality in the layers between the floor and ceiling. We have also a variety of different collaborations in terms of interdisciplinarity. One thing that, again, started here in LA, and we're still continuing that, is the possibility to work together with biofabrication labs. There is this one at Drexel University we've been working on now for some time. For me, interesting in the extent that they have something that is a 3D printer for organic matter. So actually, their idea, of course, at the end of the day is to produce organs. I mean, you know these examples. But they already are quite far in that they are already successful in doing cartilage and veins and things like that. And we're trying to understand how we can use this idea to create, let's say, variations of material. And our collaboration is in that extent that they have to create, they actually figured out that all these kind of constructions that you have to make has to be based on specific models that are, let's say, they say organically shaped. And they have to find methods on how to do that. And the exchange is that we try to inform them about the possibilities they have to reproduce these sort of forms, and on the other hand, we try to get knowledge about how they can actually do this kind of 3D bioprinting. Again, simulations. This, again, I have to say that at the Austrian Pavilion, we actually tried to do a couple of things that somehow helped us in understanding how the building behaves and how it can actually be responsive to specific conditions. It is not so much only about, let's say, optimizing things. You saw before that we have this kind of evolutionary process that led us to a specific form. But this form is not only driven by, let's say, the performance, but it is actually a combination between desires, between the ideas that we have as a specific sensibility, and of course some parts are performative. But as in nature, I mean, in nature there is actually, you have to be aware that nature does not optimize, it just changes. And that within this process of change, there may something popping up that can be functional or that can be interesting or sometimes just plainly beautiful. And I think that these kind of combinations create a possibility to select opportunities for a project. Fabrication is always an important part for us. It has become, of course, you know, almost ubiquitous in the meantime to use parametric modeling or parametric techniques in order to subdivide elements to fabricate them. It is very practical, I have to admit. So, but I like the fact that actually a specific form can be divided just into numbers and into elements that at the end of the day comprise a bigger whole. But let's go back to another idea of fabrication of design. This was actually about a part about the Austrian Pavilion, which is about the fabrication parts. We tried actually to include as much as possible any sort of computer-controlled fabrication in the design. So what you saw just before, the steel construction was actually laser cutted. All the areas of this model that are actually really strongly curved were CNC milled. And of course, it also went right into the point of also, you know, using these techniques for the furniture that were also following the same idea than the entire building. Here we have an example. That's actually the shop desk for the pavilion. It is actually following, of course, the same idea of the topological bodies. So it is related in a way into the entire design process. There's actually this great company in Austria that it's called EDM Design, that not only have the, let's say, machinery to do these sort of things, they also have the sensibility to get it right, to get it, you know, in the right quality, in the right surface conditions and so on. So this is an interesting moment where we have started to collaborate with these guys. The facade actually is made of porcelain. There's a specific reason for that. It is sort of a you know, very, let's say this visual idea. You have to know that Vienna is not the oldest producer of porcelain in Europe, but the second oldest. So actually there was this idea but it was kind of an obvious idea then to say, okay, if we have this kind of connection to such a Chinese material, let's try to use that. And it turned out to be an interesting selection. As you can see here, I mean, you see that in the entire pavilion there's no big gaps, there's no big joints anywhere. It's basically comprised of these kind of millions of joints. I remember that we were working on the model and we already started to see how we're going to subdivide it and so on. Like the same like with the Atelier Brancusi, you know, how we're going to divide that into specific panels and so on. And then we were starting to work with this idea of using small tiling for this. And one of the engineers told us, well, actually you don't need big joints because you have like millions of joints actually, and they expand and contract simultaneously. So actually you don't have the problem to create this kind of big separations between elements that start to expand and contract in a way. So it has this kind of very soft and weak condition of expanding and contracting. And it's easy to clean. I mean, that's also kind of something that works quite well. Interior, this is the exit. The shop with the finished desk inside. The restaurant. basically speaking, in the restaurant, we had a couple of, let's say, trying to understand how we can actually connect different elements with each other. And this is the stair that goes up to the restaurant. As we actually really tried to, let's say, the entrance areas are the ones that have the biggest amount of red coloration. So it's actually a play between the let's say, white areas and the red. And also this entire tiling and the entire covering of the surface went also over the roof. So it didn't stop just somewhere and then you had like a simple roof with machines on top of it. We really went over the entire roof and included all the machinery again in this kind of thickness of the surface. Which was kind of a thing that, unfortunately, I don't have any photograph of the pavilion from the Dutch pavilion looking down, because that's actually where you could see the roof completely and you really saw how it actually is made of. It's comprised. VIP bar, VIP area. We actually teamed up for this project with another Viennese company called Cetinoglu. I always say that we got like about 93% of what we really wanted to do, we got done. He says it's 100%, so it's okay. I think I'm probably more on the real side. This is actually the one day before the opening. The pavilion was visited by 3.5 million people in 6 months. So I actually was there like pretty much at the end of the expo. I was surprised how well it stood up, because I mean, if you imagine like 3.5 million people walking through a building, I had like in mind that everything's gonna look, you know, a little bit rustic at the end of the day, but it held up quite well in terms of materiality too. The opening was May 1st, 2010. It closed October 30th, and it was demolished pretty much exactly a year ago. So it doesn't exist anymore. Gone. In the same lineage, you know, of the topological bodies, there's actually a couple of projects that I just gonna go briefly and fast through. This is our contribution for the competition of the Dam Maribor, Museum of Modern Art in Maribor in Slovenia. This was for the Hong Kong-Shenzhen border competition. You see, I mean, they're basically all talking the same language and, you know, kind of still moving in the same lineage of topological bodies. And this is a high-rise project we're working currently on in China that not only tackles this idea of this kind of continuous body, but also tackles a problem of, let's say, a rustic facade, something that looks very rough from the distance. And the last one in this line is a project that we made for Microsoft in Austria. They have this headquarters in Vienna, which, you know, they have this kind of huge, large lobby, and probably as any sort of software company, they have this huge collection of media art. And they wanted a place where they could display this art, and simultaneously it should serve as a let's say, small meeting area where a couple of people could sit down and discuss maybe a specific project. What you see here in this kind of frame, there is this curving elements. This is another piece of art. It's called The Displacer by a guy called Friedrich Wienermann, one of the younger generation of media artists in Austria. He would hate it if I would say he's a media artist, but that's the way it is. And this is the sort of pavilion that we created for them. After seeing the first iteration of this project, they asked us to change it in a way that they could disassemble it and get it also to conferences and road shows and things like that. So it should become more kind of a mobile pavilion. And at the moment, we are actually working on how we can actually, you know, take it apart and put it back together quite fast, which is a bit of it's hard to get because it's quite heavy. So you have to work on the technical part to make it more lightweight, but also to make it more accessible in terms of shipping it around. Now, in a completely different, now we had this kind of, you know, this entire lineage of topological bodies. Another series of elements or series of ideas that we have been working on is about components. And we were actually trying to understand if we can find an alternative method to just taking components and repeating them along a surface. So if we can find something that is not as rigid and not as rigorous, but more loose, more vague in terms of how it behaves, that will become interesting in a way of exploring one or the other condition in space. Again, like with the linear Schof topology, in this case we were not so interested of creating right away a project. That's not the point. The point is really just to explore techniques, to explore spatial conditions, sensibilities, all this sort of coloration, chromatic effects, all these sort of elements that can that provide to the behavior of the result, and see how we can use them in a project. Now, again, this is not the project. The project comes later on in the process. It's first of all, an area of exploration. Yeah, spitting out elements. Because, and there it goes. Of course, these are repetitive. There, oops. Whoa. Let's try to get rid of this. Okay. So another exploration that is related to this first idea of components is this animation here, which I mean, in contrast to the first one, this one has a little bit of variation in the components. So it's not really like super repetitive like the first one. This has actually more kind of a let's say funkiness to it in terms of that it changes within the process. But again, this is sort of an exploration about apertures in complex curve geometries, the containment that can be created by the component. It can be the containment within the component, but also how the entire group of them creates a frame of space. And as also with the first animation, it is also about this kind of color effects and how they actually generate a specific effect. Again, not something that is a project per se, or let's say a building. It's not about the building. It is actually just about the possibility to explore what could become the building, what could become the project, which comes along the way when a specific idea is needed in terms of design. And this is actually in what it resulted at the end. This was a competition for a Japanese clothing company that was looking for a new idea for their boutiques. And we came up with this idea because they wanted actually something that works in different environments. It should work as a freestanding pavilion. It should work as a shop that you just put on the street. It should work as a shop-in-shop design in a shopping mall. And we came up with sort of multi-layered condition element that provided us with the possibility to make an enclosed element, make something that can be freestanding as a pavilion, or that also can be in a shopping mall. And our idea was actually to create a complex node. This was still the one in the middle, and flat cutted sheets that actually are connected in the node. And because these flat sheets have a specific flexibility to them, they allow us to create a variation in the connection of their elements. So you could actually create a variety of different shops that are of course all related, and you can recognize them as one specific line, but that actually can be responsive to the space that is actually available. This would be actually one example of it, where you have this shop that would be just an empty shop on a street, or this sort of idea, and the varying layers actually give you the possibility to create different effects. So that would be the shop, and also using specific elements like filaments to also give them a programmatic point. So instead of just creating some lines where you hang the clothing in it, we tried actually to include every sort of quality that is present in the sensibility to really get it done as to really work also as a boutique and shop. When we did this project, I think it was probably some of the first times we were using actually software that was able to recreate the color, this kind of color bleeding effect, which I actually think is quite an interesting field of exploration. How actually varying colorations can create different hues within a space. Unfortunately, we didn't win that one, but that's the way it is. Tessellations. There's a variety of tessellations in space, also again following this idea of components, but here in this case it is more rigorous than the first ones that were actually more free and loose. These kind of components in space can also be, of course, in this case it's spheres actually that create this sort of complex space. In this line of thinking, the first thing that we did actually when it came to design a result was actually this exhibition design for the Austrian winery boom. Just to give you a little idea of why this happened actually, why is there actually an exhibition about Austrian wineries. The thing is that pretty much 25 years ago there was a huge wine scandal in Austria because the vintners started to mix the wine with antifreezant. And the reason for that is that the glycol in the antifreezant makes the wine more sweet. So actually they tried to sweet up the wine with antifreezant, of course completely illegal. I'm not really sure if it's really healthy, but nonetheless, I mean the result being that the Austrian wine industry was completely ruined because no one was buying Austrian wine anymore. So what happened in the process is that all these old vintners just gave up and said, okay, I don't want to do this anymore, and just gave the wineries to their sons and daughters. And these guys were all educated in France and in Italy and Spain to make wine. So they actually knew how to do, qualitative wine. Before that, Austria was just going on to quantity. They wanted to do as much wine as possible. But I mean, we don't have so many winemaking regions, so you cannot compete with Spain or Italy. So they came up with the idea to do, let's say, small is beautiful. And at the same time, it became quite a successful process. And around the time also Austria became a member of the European community, and the European community started to subsidize the wineries because they knew that they're in trouble. So money was flowing in, and the result at the end was that all of these young winery guys started to build new wineries. And in the last 15 years, we actually have a nice collection of really beautiful wineries all over Austria that the Architecture Center in Vienna wanted to show. Now, we actually got the commission to do this. And we had the following problem. It had to be transportable. It had to be easy to assemble. It had to be lightweight. Every vintner was actually showing a wine bottle, so you had to protect the wine bottle so it doesn't get stolen. There were a series of models that also had to be presented. The graphic design was already done, so we had to use that. And we came up and tell them, actually what you need is vitrines. But the problem with vitrines, like conventional vitrines, it's a wooden box that has like a glass on top of it. And it would have been way too much volume to transport. So we had to find something, a more alternative model to that. And what we came up with was a vitrine that's actually made out of two components that are stackable. And it is actually a family of three different elements, three different pots, with a population of about 56, I think, of those pots that were distributed between some on the walls and some on the floor. The first time that we showed this project was actually in the Austrian Cultural Forum in New York. And from there, it was actually considered really to make a US tour, so it was actually on show in New York, and then from there it moved to LA. It was here in the Moda Gallery, as far as I remember. And then moved on to Napa. We also learned that in the process that it's probably the best thing to do when you have a traveling exhibition is that you have to take along your own light, because you never know what you're gonna find where you have the show. So if you want to rely on a specific atmosphere, you have to go and make it yourself. Of course, the plasticity of the material allowed us to do this kind of variation of luminous effects, which actually work quite well with the bottles, the backlighted and so on. So this, and also the graphic on top of it, glowing on top of the pot. So this is actually how it looked like in New York. It was kind of a more linear distribution of elements. And of course, this is loosely based on something like a tessellation. I mean, you see that actually the elements are somehow overlapping. They allow you to tessellate specific areas. It is somehow vaguely based on hexagons. They are sort of distorted. So there is this certain moment of uncertainty in the entire design, which at the same time also makes it interesting for me. And this is actually how it looked like in Napa Valley. This was probably a highlight for this Windmills in Austria, that they actually showed their wineries in Napa Valley. It was kind of I think that was the highlight of the tour. And of course, I mean, a variation in terms of tessellations. This one here was more rigorous in a way that the first time around we tried to, it was the first time that we tried to vacuum form things and so on. I remember when we were here in LA, okay, you know where to go if you want to vacuum form something. When we were in Vienna, we were like, oh, where the hell are we gonna vacuum form something in Vienna? I mean, there's no film industry, nothing that has actually this sort of machinery. But then we figured, well, Vienna doesn't have a film industry, but we have theaters and we have operas, and they also have workshops. So, and then that's actually where we found the possibility to do these sort of things. And this element was also more rigorous in a way that the first time around we used this kind of steel legs that somehow didn't really fit completely into the language of the design. The second time around, this time we also were able to vacuum form also the legs and try to get it in a more continuous fashion, the entire design to work in a more continuous fashion. Additionally, it created the possibility to have these sort of layers, empty layers in between, these sort of delaminated elements that allowed us to include the light and include other things without being visible even from below. These are all the pieces of the exhibition coming together. You know all these sort of images, forms for vacuum forming and so on. But the more interesting part being that when the Architecture Center in Vienna, when we first showed them the design of the exhibition, they were like, "You're sure you can do that?" And we were, yes, I'm sure we can do that. And also in the budget, yes, it's in Vienna. So let me just pick up my laser again, and tell down here. So, okay. Let me add something here which I think is an interesting point, which is the idea to include the functionality of details, or the program of details in the surface. So, of course, I mean, you all know this, let's say, corrugated surface effects that you can get when you vacuum form CNC milled surfaces. This one here is the one I'm interested into, which is the fact that, I mean, in order to connect the pieces of the pot, we actually relied on the ever popular zip ties, with the problem that if you just perforate the surface and you just get the zip tie through, and you have to do that many times, chances are high that you're gonna break the pot there. That actually the stress of the zip tie is gonna, make cracks in the surface. You can solve that. You can just take washers and distribute the forces, but on the other hand, that would be like probably the worst thing to do in such a surface because it wouldn't fit at all. It would look probably pretty stupid. So we actually came up with the idea, instead of creating the washer, to distribute the forces by bulging the area, which actually helped us to distribute the stress in this area. And that's actually what this sort of mound, what this sort of little volcano is doing, and it turned out to be quite successful in terms of tackling this problem. So again, it had to be, it had to have the possibility to change in shape and change in its distribution without compromising the exhibition as such. So you always had to have the feeling that the exhibition was exactly done for that space. And it's still on tour at the moment as we speak. I mean, it was first on show, I think, in Venice and Milan, Munich, and I think some of the images here are from the Galleria Edes in Berlin. Yeah, that's the Galleria Edes. So it has been traveling around a lot, which actually proved that this sort of concept of the pot and this kind of composition that works fast actually worked pretty well in terms of setting up the exhibition very fast. As we speak, the exhibition is getting prepared for shipping to China, so it's going to be in the Hong Kong Shenzhen Biennale in December. But let's continue with this kind of lineage of the components and the tessellations. This is actually a sort of chess game that we designed for Swarovski. It is not the traditional chess, as you can see, of course. I mean, it's based on hexagons. And we didn't invent this. This is actually an invention of a German mathematician named Kirk, who came up with the idea to create a chess game that is based on hexagons and that works also with a minimized size of figures. Again, talking about a specific evolution, a specific family of objects, they're all related to each other. It's very clearly visible that there's one generator, and then the rest is actually extruded from that one piece that created the first iteration. Actually, when you talk about sensibilities, when you talk about intensive forces, when you talk about solar radiation and wind forces shaping architecture and so on, it can happen really fast that somebody comes and says, okay, look, I have a shop which is selling solar panels. Can you do a design for me from the shop? Of course, why not? So actually, this is a design for a shop in Carinthia in Austria for a company that actually produces and sells solar panels. I mean, there's more that I could tell about that, but specifically what I was interested into is we had this kind of white element in the back. Let me see where it is. No, it's not in the pictures. I think that was already visible before. I mean, there's actually, this is not our robot or anything. I mean, it would be cool to have one, but that's probably not possible. But there is actually one robot in Vienna, in the Danish University, where we actually have the possibility to access it and produce prototypes and some ideas. And I mean, honestly, I think that the 7-axis robot, I'm not so sure if it's such a great tool for the academic environment, because it's so much more complicated to use than a 3-axis milling machine, that you need to put way more effort in creating the files for the machine. We also have been involved in some small amount of product design, I mean really small amount. This, for example, the guy who was actually producing all the furniture for the Austrian Pavilion, he actually asked us to design for him a desk. And there it is, finished piece. I think it can be even ordered in his office, in his company. What's interesting for us actually is to go for, again, these sort of details, like what I was saying before, including the quality of detail in the surface condition. So this kind of, orifice that is happening here that actually is just sort of eating all the cables. I mean, it's funny how actually, this kind of very conventional computer stuff looks a little bit old-fashioned on such a table, but actually you have to find a way how to make it fit. Something that we made for the MAK shop in Vienna, a sushi board, actually. So you just put the sushi on top of that, and it's standing on this ornamented surface. American black nut wood, I think, something like that. Turned out actually nice out of the milling process. And talking about the MAK show, a couple of words about the MAK show. We're always looking for new possibilities to find something that somehow engages us in a specific discussion. In terms of geometry and mathematics, we're always looking for something that inspires us and gives us ideas about what we can do with our own work. And the MAK show actually came, I think, at the perfect moment, because I think like 2 or 3 weeks before the question came to make this show, we actually started to explore again recursive geometries, meaning that I mean, we all know the term fractal. We all know this all these Mandelbrot things from the 70s. It is something that has been discussed to full extent probably. The new dimension on what is going on here is that instead of having a planar 2-dimensional image, you start to have something that engages 3-dimensionality, which engages space. And not only that it engages in this sort of discussion of space and depth and 3-dimensionality, it simultaneously also has, funny enough, all these kind of resonances of Jugendstil, of Gothic, of Baroque, of Rococo. So it has qualities, inherent qualities, that actually pick up sensibility, these kind of obsessions that Sandra and I share, and transforms them into a 21st century environment. So it is not about copying ideas that are 300 years old. It's not about reproducing form. It is actually about more or less reproducing a sensibility in a contemporary environment. So these sort of things were let's say the starting point for the MAK exhibition, and we actually put some time into exploring how we actually can generate these things in 3D. It is still a process that is going on, and that's the exciting part about it for me. It is more about an explorative field that we don't know exactly where it's going. We don't even know yet how we're going to include that into one architectural project. We just have some hints, some possibilities, some, let's say, taste of what it's going to become. This is, at the moment as we speak, we're trying really to understand how we can create sort of opulence in a specific architectural project. The show was, I think, from March to September this year. At the moment, one of those pieces is also an exhibition at the VAF in Barcelona. Of course, it is more for us ourselves at the moment. It's more a riddle than really something that is a line that will lead to a project. But I highly like. I mean, I really love the way how these formations of recursive geometry start to behave as something that is extremely ornamental, is hyper-articulated, and engages three-dimensionality. And with that, I would like to leave you to watch this couple of minutes, and thank you very much for listening. I noticed there's something missing here. This needs sound. Thank you.
So we're willing to take questions. Great. Do you want to start?
Now, does anyone have any questions?
Wonderful presentation, so that's, but what I'm so interested in is in this quest for beauty.
Yep.
So often, the very same equations and parametric explorations that move one wind up with a kind of Gothic darkness, and which is highly associated with form design. And so your images tend toward the ecstatic, the rhapsodic. And how, in your manipulation of these forms, do you manage to drive them in this direction, which has, you know, more to do with the kind of culture of the Goetheanum and the, you know, the sort of ecstatic art experiments of the 20th century and so on. How does that happen within the same set of equations?
I mean, maybe that's exactly the point. It's the same set of equations. I mean, if you think about Gothic architecture, it's all based on the circle. What's it called? The circle. I don't know how it's called in English. Exactly. It's all based on compass. It's all based on how actually you start to subdivide a specific area only with parts of curves and parts of circles. And I think that, I mean, that's the one side. The one side is, of course, the geometric part. But the other, of course, being, I think, a very, very conscious way of tackling a specific, let's say, aesthetic or sensibility. So, I mean, I think that the work that I've been doing has always tended more to the dark side. Yeah. So I think that, I mean, a friend of mine once said to me that he would like to be so dark, but he cannot do it in a way. So I think it's a matter of sensibility. It has to do with the geometry, it has to do with mathematics, it has to do with this part, but it also has to do with the desire for a specific sensibility. And I think also that this anti-romantic thing also goes into this area. Like, I mean, if you think about this anti-Sturm und Drang romantic idea, it always tended also to the, let's say, more dark area.
Well, okay, but then I think you're interpreting a bit of the last sequence. If you were scuba diving in a sea of forest, it would be an ecstatic kind of experience. It would not be a dark experience. And that's what I'm referring to. This has that quality of the natural splendor and beauty, which I find unusual given technology.
I think one of the things would be that a lot of parametric generation of form ends up focusing on structural expressionism. And it's been primarily used for structural optimization and assembly of linear elements and things. And it seems like that aesthetic of structural expression would be very Gothic, and is also something you're not particularly interested in. And it seems you're more interested in surfaces than complicated frames or something.
Yes.
So, I mean, for me, that's why it's so much of that parametric work is Gothic, because it ends up landing in 90% structural expression, where structure here is concealed behind surfaces, or is part of the surface.
It's actually, the idea would be it's part of the surface. Like, for example, for the Austrian Pavilion, we were trying to find a method how we could actually use the curvilinearity of the object to really get those forces down, but we learned a lot in the process that it's not possible to do it as we thought, because you need actually a specific amount of curvilinearity to get to really tackle the stresses. Otherwise it doesn't work. So, but I agree. I mean, and actually, I mean, you probably noticed that I didn't use the term parametricism even once. I mean, I'm not really, you know, I try to tackle it in a different fashion. There is, of course, parametric processes, and of course, I mean, parametric, you know, parametric modeling is basically more a mode of working than really a style. Anything? Don't be shy.
I have a question for you. I was kind of struck by the way in which forms are scaleless, and that your basic formal arrangements shifted from the scale of furniture to the scale of pavilions. And as you started to go over the exhibition design work, some of that changed a little bit, and I saw more programmatic demands and kind of other issues driving the configuration of the forms in a way that I found hopeful and compelling. But I wonder if, what kinds of sources you studied in order, so we see the last experiment, which is really filigree and kind of finely articulated, but there are so many things that I think in popular culture that would inform how you might handle surfaces at other scales. And they have a little bit to do with whether you hide structural capacity or express it, but in all sorts of plastics, from the scale of toys to the scale of, larger scale, I don't know, like a kind of fiberglass part, that something about manufacturing and the kind of forces applied to a particular part start to change the potential of expression at that scale. And in your work, you seem consciously to reject that. And I wonder if it is a conscious thing, or if structural expression is ever something that you might adopt, or that might change your surfaces, because it happens at the scale where the zip tie attaches to the part. That's actually a form of structural expression, just dealing with the distribution of that ring, but it happens at a kind of micro scale. So I don't know if there's a question in there, except that I'm just blathering on. But I guess I'm a little suspicious of the scalability of diagrams of surface to aperture relationships, and I'm kind of interested in where the work goes without going all the way to the opulent and the decorative, is what other kinds of models might work on the issue of aperture to surface, or the way in which a surface touches the ground, because you're clearly dealing with that in the pavilion, and then dealing with it at a completely other scale in an exhibition pod, but they're handled in the same way. And I'm wondering, what the kind of lateral development of the problem of complex form hitting the ground might be.
Was that a question? I mean, actually, when we talk about the scalability of objects, I have to admit that probably I have to go back to my education with Hans Hollein, who was always about scalability, and was always about that you can take a train wagon, and scale it up to the size of a monument. So maybe that's something that somehow resonates in this work. I mean, on the other hand, I can totally imagine that you can play with these kind of scale problems, and I think that the problem starts to become more specific, like in the case of the zip tie, once you have the problem in front of you. And that's of course a matter of planning process. We haven't done so many buildings yet, so we didn't have the problem so often by now. But it's going to happen in one way or the other. And of course, I mean, this kind of shift that is visible now with the last work in what we're doing was very conscious. I mean, it was kind of, we need to try to go away from this kind of research that we made over years about just surfaces and how they touch ground and how they actually, create openings and so on. We need to, move into a field that provides us with another sensibility. question.
I was curious, the work you do with pretty rigorous math concepts, is that something that expresses a long-held interest, or are these topics that you discovered were just kind of useful for your purposes over time?
Good question. I think that the interest evolved over time. I don't think that, I mean, it's not that I was always, let's say, a math hat, right? But it just evolved within the use of the tools too. I mean, as soon as you start working with any sort of computational software, you're aware that actually that is based on specific algorithms, and that it actually, you will profit about understanding what is actually happening in the background of the program. And that's how actually this kind of interest for geometry or for mathematics actually emerged. And finally also led to this kind of more trying to understand rigorously what's actually happening and how can we apply that. Which actually also for this entire scripting and grasshopper thing and so on helps a lot, of course, in terms of understanding how you can structure such a definition.
I'm just curious about one of the things you started to talk about in Pavilion, because there you were really dealing almost completely with a system that was fundamentally hierarchical, and the sort of, you know, the expression of the piece itself is so unhierarchical and without certain. You started to talk about how there was an initial inquiry about whether I could use the surface of distributed forces, and in this case, the building without stressing a way of allowing the surface itself to be also different. But ultimately, you know, you ended up with a building with a million expansion points, so each tile has absolutely, you know, blur sort of back to the surface. So I was just wondering what your thoughts were in sort of rationalizing this sort of, you know, initial set of ideas about the building and the sort of, you know, ultimate construction.
Yeah. I mean, my first thought on that was May 1st, 2010. Had to open. So, of course, it would have been possible to keep exploring the possibility to use with it. I mean, at the beginning, we wanted it to do in concrete, with, you know, trying to use the surface as something that is structural. It turned out that if you do it that way, we need to change the design extremely to get it to work in this kind of way. So we actually needed to find another method. Another thing is actually something that is very banal in a way, is that at the time when we were starting to design the final construction of the building, the steel price dropped dramatically. So actually we had the possibility to do a lot in steel instead of, you know, using concrete, which gives us more precision. So actually this is a very specific way of tackling that problem. I understand the critique in terms of being a, you know, a sort of hierarchical system of structure. I can second that immediately. But it would be actually an interesting idea to, I mean, the next time we have the chance, we're going to try and make it really the way we, I mean, in terms of becoming a structurally consistent element. Does that answer that?
Yeah, just, yeah, I mean, there's no answer to that.
I'm not sure if it is about organic forms at all. I think it's just a matter of, you know, I mean, one thing is the program. One thing is how the building behaves, what you want it to do. I mean, in your case, you're talking about a theater, and that has a very specific program in our case. You know, You have an entrance, you just try to find your seat, you see the play, and so on. So I'm not sure actually if I mean, this kind of program can be fulfilled with almost any sort of form, so it doesn't matter whether this is now in this or the other way, right? But it is, I think, absolutely a matter if it becomes a specific quality of the design in terms of sensibility, like saying, okay, this has to have a specific atmosphere, for example. You start to talk about atmosphere in architecture, then you start to talk about coloration, and then you start to talk about articulation of surfaces. And look at this here. I mean, there's more going on here than just what it does in terms of seating people, right?
But I think all of the questions are kind of asking you, of course there are constraints and exigencies, but there's also tectonics and typology and things like that. And I think the questions are just asking you, what's the status of typology in your work? I mean, there's having a performance, but then there's also having a theater.
Yep.
And your response to the typology of a theater, you expect certain things, and so when you change them, it's critical, or
Yeah, I understand the question.
But so, what's your? How important are historic things like typology and tectonics, or are they not important at all? Or does the computer let you just bypass them?
No, they don't let you bypass that. I don't think they let bypass that. I think that it has a lot to do with. I have to explain something before that. Sandra was actually in a technical high school for drafters for architecture, so she actually knows a lot about actually any sort of typology. Yeah? My own education at the Angewandte at the beginning was all about typologies. So what I think is that in both our minds there is something like a back program in action that we don't have to call up all the time. We just know how specific things have to be designed so that they work. So whatever we start to design, there is of course a sort of a backup routine that helps us to tackle specific typologies without having to really express them and say that's the typology A, B, or C. It becomes readable through the project itself, I hope at least. Yeah. So that's actually the idea behind it. It's not that we're despising that, or it's not that we're just saying we forget about it. No. I think it's about really including all these sort of layers of knowledge into a project that at the end of the day will perform in a specific fashion. You're welcome. Thanks for having me.